Now let's look at quantitative data. Okay, as opposed to qualitative data is any data that you can use to calculate and will give you a meaningful outcome. Okay, and as you can see here, right, rather than just stating quantitative, I did put down in a bracket interval and ratio. This is actually the categories of quantitative that are previously known. If you look maybe in other books, you will see that the type of data we categorize by this: nominal and ordinal for qualitative, and interval and ratio for quantitative. That is one way to actually classify it. Okay, but for your book, we did not classify it by using interval and ratio. Why? Because first of all, interval and ratio is actually not much difference, right? Sometimes it is actually quite confusing to differentiate between interval and ratio, and most of the thing that can be done with interval and ratio is similar. Okay, there are just some distinct characteristic between interval and ratio. You need to know that for now. But what's more important, based on this book, you'll need to differentiate discrete and continuous. These are the two kinds of quantitative data being explained within this book. Okay, so what does it mean by discrete data? Okay, if you look at this, discrete and continuous. Actually, let's try to look at page 6. Alright, they give you an example of discrete and continuous data. For discrete data, the example is number of students, number of defect, number of votes. Or in other words, any number that can only appear in a whole number, 1, 2, 3, 4, 5, and so on, is a discrete data. It's known as a discrete data. Anything that you can think of, if can only be displayed by whole number, is a discrete data. What else can we have? A number of if you look at number of persons, right? Number of persons, number of books, number of laptops, number of things. Now, usually tangible things is in the whole number. It is, if it is impossible to have 1.5 students, it not making any sense. You can only have 1 or 2 students or 3 students. So in other words, the discrete data, right? For the discrete data, after 0 is 1, after 1 is 2, after 2 is 3, after 3 is 4. Okay, those are what does it mean by a discrete data? Okay, after 1 is 2, after 2 is 3. Okay, let's look what is the difference from it between discrete and continuous later. So as for continuous, right, it is not actually can be displayed by a whole number. It is actually, in fact, can be displayed by any number in decimal, right? So if you look at the example here, we have height, weight, time, income. Those are an examples of things that can be displayed in decimal. So for height, you have 124.4. They are using 1 decimal. And then you have income, 5,800.50 cents, or 7,360.85 cents. So 2 decimals. But that is not the limit. For continuous, it can go further than that. Right? It can go more than 2 decimal, 3, 4, 5, 6, you name it. You can go further than that. So that's why the name is continuous. Why? Because if you are to write it down, right, if you have, let's say, a scale, we put a line, draw one line here. For discrete, you can say, okay, now you put the first one is 0, the next one is 1, after that is 2, then is 3, is 4, is 5. You know that it is a whole number. As for continuous, what is, just imagine a straight line here. you have the first number is 0. What is the number after 0? It is not 1, because we still need to consider the decimal. You have after 0 is 0.000000000. It doesn't matter how many 0 that you put, 1 at the end. So you have 0.0000002, and you will have it until, just imagine how many number that you will go through before you reach 1. Almost infinite, because there is too many decimal. The number of decimal is actually literally unlimited, even though they have a limit, but usually we cannot actually able to possibly calculate everything. So just from 0 until 1, the number is too many. We cannot have enough time to zoom in, right? So from 0 to 1 only, right, the scale, if you want to put a scale there, it will be close, too close together. So it seems like it is continuous. As for discrete, after 0 is 1. There is no value, no other value between it. After 1 is 2, right? Because it is a whole number. It is represented by a whole number. As for continuous, it has actually, an infinite number of numbers just between 0 and 1. The same goes for between 1 and 2. You have 1 point something, right? There's a lot of other numbers in decimals before you can reach 2, and so on and so forth. So basically, because of that, it is known as continuous. Okay, and before we end up on type of data, if you look at the book, you have actually a discussion on group and ungrouped data. We're not going to cover that in detail, right? The one that we're going to cover throughout this this chapter is actually just on ungrouped data. What does it mean by ungrouped data? Ungrouped data is actually just a data that you collect and you actually look at it. The data that can be said as almost as a raw data. Just imagine that you do a survey, right? Let's say a survey on how old students in our class. So you just go and make a survey. You ask their age, and then you jot it down. You type it in your computer, and that is actually known as an ungrouped data. A data that not being grouped yet. Just like in example 1.5, table 1.5, you'll see that an ungrouped data is a data of internal ring gear width. This is actually the example used here. It's just a data that is not being arranged. As for a group data, it is a data that being grouped together and then being represented by a frequency table. But as I said, we are not going to cover group data, so we are going to stick just with the ungrouped data. Okay, so for our next video, that's it for type of data. For our next video, we are going to start looking at the graphical data presentation. Thank you.